So we're gonna do problem number 28.11, and it goes like a straight wire carries a 10 amp current. ABCD is a rectangle with the point D in the middle of the 1.1 millimeter segment of the wire and point C segment of the wire. Find the magnitude and direction of the magnetic field due to this segment at point A, point B, and point C. So it's saying that we have a rectangle ABC, we have a wire, and we have a rectangle over here at point A, point B, and point C, and point D. And here, we can draw a segment over here, as shown in the book. And from the distance from here to here is 5 centimeters. The distance of the length is 14 centimeters. The distance of the segment is 1.10 millimeters. And then the current is 10 amps. Okay, so here we go straight to the question. That's how you usually use solve these problems. You go straight to the question. So it says, find the magnitude and direction of the magnetic field due to the segment at point A. So let's do, when it says the magnetic field, then we could do this for a point, which is this is the formula. But right now we are solving it for a short wire. It doesn't say it's very long, so we're gonna do a dB, and it's mu sub naught over 4 pi times q sub v cross r hat over r squared. Okay, it can also be written like this: the law of u sub r is mu sub naught over 4 pi times I dl sine of theta or phi over 4 over r squared. And right now we know what mu sub naught stands for. We know what we got 4 pi, and we got the current, which is 10 amps. We got the L, which is 1.1 millimeters. And we know that the angle of sine of theta, the angle is, if we're talking about point A, then the angle is 90 degrees, because it's right here. It's 90 degrees to the wire. And then, so we got that. And then r squared, the distance which of r is the distance from the wire to the point. So that's 5 centimeters. You can see here. So 5 centimeters. So let's convert that. 5 centimeters, 1, 2, so 0 meters. And then over here is 1, 2, 3 for the segment. Meters. So if we just plug in, dB is equal to 1.0 times 10 to the negative 7 Tesla meters per amp, and we get that when we divide mu sub naught over 4 pi. So it's times the current, which is 10 amps. Okay. Times the L, which is 0.0011 meters, times sine of 90 degrees, which is 1, over r squared, which is 0.05 meters squared. Okay, so we cancel meters. One of the meters because of the amps, and we are left with, well, we cancel meters again over here with the other, and then we are left with, the answer will be, when plugging all that in the calculator, we get 4.40 times 10 to the negative 7 Teslas. And this will be going out of the paper. For part B, we get this point over here, and this is the distance, and this is the angle. So we gotta get the angle using the 5 over 4 over 14, I mean, centimeters. So it will be tan inverse 5 over 14. So tan inverse 5 over 14, it will be 19.65 degrees. And then the distance from one point to the other, from B to B, would be 14.8 will be the distance from A to B. Distance from A to B. Meters. I'm sorry, that's centimeters. 0.148 meters. Okay, so if we plug in these values and we plug in onto the formula dB times 10 to the negative 7 Tesla meters per amps, and 10 amps because we're still running 10 amps, and 0.011 meters for the DL, which is the distance of the segment. And we just change the angle, which is 19.7, we came around, over R, which it was now 1.148 meters. Then we can solve, and we will get 1.67 times 10 to the negative 8 Teslas. And this will be also be coming out of the paper. For part C, is from D to B to C, D to C. And from here to here is it looks like it's 180 degrees. Or it looks like it's 0 degrees. I'm sorry. So 0 degrees, so sine of 0 is 0. So if we just plug in the formula, dB is equal to mu sub naught over 4 pi I dl sine of 0 over r squared. Sine of 0 is 0, so 0 times everything is equal to 0. So part C is equal to 0.